Meow. I've always liked cars. I mean, ever since I was able to pick up a wrench, cars have been fascinating. And there's a lot of science that goes into a car. I mean, you have fuel efficiency, and you have crash safety, and you have aerodynamics. But there's probably one little bit of science that has to do with cars, or a lot of other things for that matter, that you've probably never actually thought much about. I'm sure you've been here before. Not Nicholas Sharon Park, but next to a busy road with cars and trucks passing by. They all have that strange sound, that meow. It's kind of a weird effect, but this weird effect has a name. It's called the Doppler Effect. Alright, if we're going to talk about the Doppler Effect, we need to talk a little about sound. Now, when something makes a sound, it emits a sound wave. And that sound wave has a particular frequency. And frequency determines the pitch of the sound. The higher the frequency, the higher the pitch. Now, let's go back to our car example. Say we have a car, and it's making a noise. As you can see, it's emitting sound at a certain frequency, as in so many sound waves per second. Now, something funny happens if the car starts to move. As the car moves and emits sound, it moves a little farther ahead between sound wave emissions. So the car really catches up to the previous sound wave. And that looks something like this. Now, as you can see, in front of the car, the sound waves get compressed. So to somebody standing next to the road when the car drives by, the sound waves appear to have a higher frequency, therefore giving it a higher pitch. When the car passes, however, the same thing still happens. As the car moves away, it spreads out the distance between the sound waves it's producing. Now, this makes it seem like it has a lower frequency and therefore a lower pitch. Any internet search will tell you a whole lot about what the Doppler effect is, but what is it used for? I mean, why do we need to know about the Doppler effect in the first place? Well, the Doppler effect applies to anything moving in a wave, not just sound. Those radar guns you see the police using to see how fast a car is going, that's Doppler radar. And the way it works is the gun emits a microwave with a known frequency, and the difference in frequency is measured when the wave is reflected back off a moving object. In fact, the Doppler radar that meteorologists use to track weather patterns works on the exact same principle. And even doctors and cardiologists use the Doppler effect to create something called an echocardiogram, which creates a picture of a patient's heart and can even measure the direction and speed of blood flow. Now, if that's not crazy enough for you, think of it this way. Have you ever looked up at the night sky and wondered why it's dark? I mean, we're surrounded by an infinite number of stars in an infinite number of directions. I mean, why isn't the night sky just as light as the day sky? Well, part of the reason is because of the Doppler effect. You see, the universe as we know it is expanding, and anything that's emitting light around us is moving away from us at a ridiculously high speed. This causes the light coming from those objects to shift towards the red end of the visible spectrum because of the Doppler effect. Now, what that means for us is that we have these objects moving away from us, and they are emitting light, but they're moving away so fast that the light they're emitting actually gets stretched to a point where it's infrared, and we can't see it anymore. So it turns out the Doppler effect is actually kind of cool. I mean, it can teach us about sound, it can teach us about speed, it can teach us about the human body, and it can even teach us about our universe that we live in. It's amazing how one simple concept can stretch into something completely and totally universal. And that's science.